Well, greetings, everyone. My name is Anda. Welcome to the fourth day of the Baltic Summer School of Digital Humanities. We have a very long day ahead of us, and it will be almost entirely dedicated to large language models. As a keynote of today, I kindly invite Sarah Oberbichler, who is a research associate at the DH Lab of Leibniz Institute of European History in Mainz. And her expertise is in historical migration studies, environmental studies, and transnational media studies. Welcome.
Thank you very much. Yeah, thank you very much for this introduction. It's really a pleasure to be here giving this talk today. It has been also very interesting for me to see some of the workshops during the last days and also meeting some of you already and having the chance to to talk to you. So yes, as Anda already mentioned, the whole day is devoted to large language models, and my talk will make the start. It's called New Approaches in Using Large Language Model for Historical Newspapers Research. I myself, I've researched with newspapers for more than 10 years. It has been one of the main fields of mine, doing studies with historical newspapers. On the other hand, the field of large language models is quite young, so it started about around 2022, 2023, that we were able to use the first models also in research with generative AI. And I've been started from the very beginning of this journey, and I've been thinking about what we can do with large language models for the historical research. And I, of course, have not been the only researchers. It has been a growing field of interest. Some might even say there is a huge hype of generative AI in research. And yes, of course, there is a hype. There's a lot of communication about what we can do, but also a lot of communication what we shouldn't do, about the limitations, about the mistakes that we can do when we use large language models. Studies that really show great results, studies that really show what are the problems, and other studies where you really have to wonder, how did this even get published? But yeah, so there's a lot of experimenting still, since it's a very young field, and everything that I'm presenting today has been my research for the last 2 years, many experiments, many evaluations, and just trying to figure out what way to go. I mainly focus today on qualitative research. I will explain more about what qualitative research is about and why large language models can be such a big change or deal breaker for the qualitative research in the digital humanities, where we focus, of course, also a lot on quantitative approaches. Only recently I ran into this paper here. It's a paper that has been published 2 months ago by my researchers from the Microsoft. And it is a study that researched what occupations or what jobs the large language models will have the most impact on. And I read through this paper, and one thing that really caught my eye when reading through the paper is that historians were on place number 2 with the highest AI applicability score, meaning that researchers came to the conclusion that what historians are doing can be very much assisted by large language models. And here also not to say taken over by large language models, but the tasks that historians are doing are tasks that can be very well assisted by using large language models. Tasks like researching, literature review, asking questions to sources, checking sources, and so on. This means that, of course, it's just a study, and we don't really know what will be the future about. But I think also for us historians, this is a really big indicator that we really have to make sure that this way of using AI in our research is going in a right way. And I think there are two ways that researchers can go, is either say, okay, let's avoid going this way because there is just too much errors, too much hallucination, I cannot trust it, or we really try to shape this way and make it the best use by actually having an impact also on how models are trained. But let's go to the historical newspapers and the potential that large language models have for the research with the historical newspapers, and especially also for the qualitative research. As I already said, I work with historical newspapers for quite a long time, like over 10 years, and more than experiencing newspapers as an easy source, I have experienced newspapers as a really, really difficult source for doing research. It's just because there's so many different layouts with the newspaper, so much different fonts, different topics on the same page, articles that are never clear defined. Every newspaper has different ways of showing articles, tables, lists, ads, images, graphs. Then there is often this very bad quality of the scans, which also comes with very bad OCR. And in the end, also newspapers is just a huge amount of data. So dealing with newspapers means that we deal with millions of pages. That doesn't mean that we have to analyze all of this, but if you want to research specific topics in papers, just to go to these topics, you really need to go through a lot of data. So my own research is about environmental history, especially about natural disaster research. And in this area, newspapers are an incredible rich source of documents of our pasts. And especially because we can learn so much from historical newspapers, how societies deal with crises, how there are culturally specific ways in how society deal with those crises, and also we get insights in successful or also less successful disaster responses. So that's specifically my own research, where I really want to understand how did we in the media talk about those events, for example, like earthquakes, very big earthquakes, how did we respond, and what impact had this to the society? I call it also unlocking past experience for the future, meaning especially also very often in the social science or in the natural science, they call for historians to actually really better understand the history of natural disasters, to understand the future of natural disaster. And the future of natural disaster is definitely a very important topic as well, since with the climate change, this will be more and more something we will be confronted by. So yeah, newspapers, we can learn from them. We can learn from past experiences. With traditional digital methods for historical newspapers, we would have various possibilities to explore the newspapers, but at least for me as a researcher interested in the qualitative research, like in the meaning of what is in the newspapers, I've always been troubled by many of those methods to really understand the meaning that we have in the newspapers. But I'm just showing some of the methods that the researchers have been using a lot when they research with newspapers. One is, of course, the frequency analysis, like the analysis of words and how they appear over the time. We have topic modeling, which has been quite often used in the last years, mainly also in connection with discourse, or also more qualitative research, trying to understand what topics are in a big corpus on specific, in specific themes. Topic modeling, however, has always been also quite a problematic method, because it's very difficult to read it. I mean, you get topics, and it might look like it makes sense on surface. But when you take a closer look, you see like the topic modelings are not putting together topics as we humans would expect that you put together topics. The statistical relevance is very different than your own experience of how you would define a topic or a theme. So that is really complicated, and actually not many researchers knew exactly how to use it. Then there are collocations and n-grams, where we just look at words that are closely together. It's all statistical methods that help like to understand or try to help a little bit the very superficial discourses we might have in the newspapers, and then also methods like named entity recognition, where we try to give labels to places, to names, to persons, to organizations, and so on. Which all of those methods are really helpful in the big thing where might be interesting discourse, or where might be interesting insight that we research further, but not really helpful if you want to use very big data for really qualitative research. The problem is that most of these methods, they track patterns based on superficial language use. That means that they don't really give access to the intention of the language. So we don't really know just by looking at words. We know, okay, those words were used, but we don't really understand what was the intention behind the words as they were used, or what was the intention to shape reality by using those words. So at least that would be my claim. If we want to understand how real-world events were transformed into socially constructed events, and with what intentions, we really need to study discourse. But let's look at a concrete example. One of the examples I have been looking into in the last year, one specific event, the Messina earthquake. The Messina earthquake was one of the biggest earthquakes in Europe ever, in '98 in Sicily, the southern Italy. And it mainly affected Sicily and Calabria, and especially the city of Messina. This is also why it's called the Messina earthquake. And it was also followed by a tsunami and fires, and it had more than 100,000 people killed and more than 100,000 refugees. So this is one event that I was paying attention to during the last years. And the interesting thing is, I mean, the natural event per se is not a disaster yet. It becomes a disaster through the impact it has to the society and how the society is responding to it. And one way for a society to respond to such events is actually talking about it, in making it a media event. Making a media event also means that the natural event that happens becomes a socially constructed event. And constructing event also means that we can use intentions to shape reality. That means from this real event, we become a media event that can be used to shape reality in a specific way. And for the Messina earthquake, there were different intentions, and I'm talking here mainly about one. So, for example, the Italian government had one very clear intention for shaping the narratives during or after this event, which was framing Italy as a very strong and self-sufficient state, also promoting strength to the world. So that was one very important narrative in all the talking about this disaster, like how strong we are as a nation, how united we are as a nation, and that we don't need so much the help from other countries or loans from other countries to manage this disaster. Of course, those narratives also have real impact, and the real impact is that the measures actually that the Italian government took after the disaster were mainly of short time and of symbolic matter, and didn't really solve the issues after the earthquake. So yes, studying intentions in media and understanding how we shape reality, how reality is created through media, means studying discourse. And studying discourse is a highly qualitative approach. For example, we could use into how arguments are created, how arguments are used, With discourse, we could also look at how we frame. It's also called the framing analysis or the content analysis. But so far in the digital humanities, the qualitative and the quantitative methods have been treated quite separately. And the mixture of both methods has been referred to as mixed method approaches or also blended reading approaches. This is one graph that I created myself during my PhD time, because my PhD was also based on this blended reading, like mixed reading of doing some distant reading, meaning like looking at words, at frequencies, and then going over to the qualitative parts and trying to analyze the arguments. But that also, for me at least, means I had to limit the study that I did, because of course I had to be able to read everything. And that also it meant for me that I had to go through a lot of material by myself and to make this work. But yeah, this is more or less how we used to combine quantitative and qualitative analysis by either go from quantitative to qualitative, or start with some qualitative and then prove it with more quantitative analysis. And of course, the interpretation is always in the end. So just to also give a little bit an understanding, when I talk about quantitative methods and qualitative methods, the main difference would be, like with quantitative methods, I would ask for what and how often, which, for example, I can get with frequencies. I want to know how often is a word being used in a very long time period. But with qualitative research, I want to know why and how. So why were these words used and how were these words used? So the quantitative methods are more statistical, while the qualitative are more exploratory. With the quantitative methods, usually I want to identify trends. So I want to know what were the trends of using language in sources, for example. Did it change over time? Why did it change? For qualitative, it's more about discovering patterns in ideas and views. So I really want to understand the intentions, the ideas, and the views of how was communicated. And the quantitative methods allow to use very, very large samples, while the qualitative research needed to be on smaller samples, because one person cannot read so much sources. Using large language models in this area means to combine basically both qualities of quantitative methods and qualitative methods, meaning having the possibility to use very large samples, but still ask the questions of why and the how, and still trying to find the discover patterns in ideas and views. I call it qualitative data analysis by using large language models. So that's the very big potential of large language models, that we actually can go beyond like treating qualitative and quantitative as two separate fields, and actually have a qualitative data analysis in very big data. I also call it a paradigmatic change in qualitative research, this step, through generative AI, which has become possible. And I make here two fields where it has really an impact, or where large language models really can assist very well in the qualitative research. So the first point is creating corpora of high quality. So for qualitative research, we really need corpora that are of high quality, meaning good OCR, but also when we work with newspapers, for example, we need articles, full article, the way as they are, and not somehow cut it away or somehow with a wrong layout recognition. We really need high quality corpora for doing qualitative research, because that qualitative means you really make use of the whole content of the article. And that's the heuristic part of the research, and then the analysis part is really making the qualitative discourse or content analysis computable, meaning that what we did manually for so long time, we make it computable, having large language models assisting in these processes. So this can be, for example, finding argumentative discourse units, like finding units in the sources that have arguments, by detecting or extracting themes from historical sources. These are just examples, and of course this list can be expanded, or by codebook analysis with historical sources, which meaning we can ask specific questions to the source and extracting specific information. And of course, I always say assisting, because it's not doing your own historical interpretation. That would be always the next step. So the large language model assists basically in getting the material that you in the end manage to interpret and contextualize. But let's start with the first point, creating a corpus of high quality using large language models. And I'm also just making sure that we know that we are still, or we always go now with the Messina earthquake case that I mentioned in the beginning, because that's where all these experiments are based on. So, yeah, I already mentioned how difficult newspapers are for like extracting the articles that you need. Traditional methods would have been, and that's shown in this little image next to the big text. They would try, based on the layout and on the graphic of the image, to distinguish or to separate articles and define semantic units. Most of those methods have never been good enough for historians to really be used for qualitative research, meaning that they were either cutting away too much or leaving too much text of an article. There are different methods. Some of those methods just go from heading to heading, but that's not how articles work, because you can, between a headline and the headline, you can have a lot of different articles. If we define articles as semantic units, like on one theme. So I was thinking about what if we could use large language models and the capability of the large language models to actually contextualize the whole text and to have a semantic understanding of the text. What if we could use large language models to extract the articles directly from the transcribed text? Just trying to give you an idea of if you had like a whole newspaper page, this is just transcribed. So this is like what after we have done OCR and layout analysis on the newspapers. So in many newspaper archives, you will find the newspapers, but then also this transcribed text. And which you can actually then use for the analysis. So what if you just use this text, and here the yellow highlighted would be one article about an earthquake. It's a very short one, but this would be basically one semantic unit, and you can see there is basically nothing else but the text that would give hints of, oh, there's an article in it on the earthquake. So yeah, I started some experiments, and what I wanted to find out is how good are the large language models in first, like even deciding if there is a relevant context in this newspaper page. So is there even an article on the Messina earthquake, or is there an earthquake but not the Messina earthquake? Then it's about the extraction, like are the large language models capable to extract the original newspaper text without changing it, without hallucinating, without changing the text? And the end is, I also wanted to know how good can it detect the boundaries? Like where does a semantic unit or an article start and where does it end? In order to evaluate this, we were setting up experiments with several models, also to be able to compare the capacity of the models. So we had 3 mid-size models, also open weight models, and 3 large-size models, 2 of them closed source, and the DeepSeek has also an open weight model. So yeah, the mid-size were around 70B, and the big size were really like 4 or 5 times larger than those. We were using local models with the open weight and the APIs for the large ones. And I was very lucky during this time because I got a student who wanted to do an internship at my institute, and she helped with doing these experiments. Basically, she did the experiments and I assisted, but I was very lucky to have someone to help with those experiments. Her name is Johanna Mauermann, who is still working with me. And so, yeah, to be able to decide or judge how good the models work, of course, we had to create an evaluation data set. So we created an evaluation data set with 874 rows, and we wanted to know it for 3 different languages, English, German, and French. So we also wanted to see if the models work as well in German and French as they do in English. And basically, the way how Johanna created this evaluation data set is doing everything manually that we expected the model to do automatically in the end. So she extracted those newspapers that she decided were relevant for the Messina earthquake, or decided that there are no relevant articles. So what she, basically the last here, the last row is the ground truth that she created, is basically deciding, okay, there's no relevant article in this text, or the most of them are here relevant, but the last one would be, if there is one, she would extract it the same way as we would expect the model to extract it. So she creates a ground truth, like basically she creates a data set that has the answers exactly as we wanted them to be, and now we can compare what is the large language model doing with this data set. Prompting was, of course, also one very big thing that we had to deal with. So also Johanna worked over a month on just defining prompts. And the way as we tried to do it is first, well, I had to explain Johanna how she had to extract those articles. So we actually thought like, well, the instructions that I give to you, of course, need to be the same instructions that we give to the large language models. So at least that both of them have the same guidelines. So the guidelines for the extraction have for us been the article is a semantic unit in the text. For Johanna, I would have defined more what is a semantic unit, but we also figured out with the large language models, the more you try to explain in detail, for example, what is a semantic unit or what is the Messina earthquake, and you actually overload the model with too much information. So it's important to give the guidelines, but not overload it with like any little detail, because the model basically understands what is a semantic unit. But yeah, we wanted to have semantic units. We also gave criteria, what is relevant. I'm cutting here a little bit away, so I was not able to show or to print the whole prompt here in this slide, because then we couldn't read it. It got really long. But we gave criteria of what is an article related to the Messina earthquake, and then we also defined very clearly how the model has to respond, because that's very important if you want to do the evaluation. You need a format which you can compare. So the articles we defined, they should be extracted in an XML text. And after that, the extraction, we also did some explainability things. Like we wanted the model to actually self-evaluate their own task. We wanted the model to decide if it needs human oversight, if it needs the help of a specialist by yes or by true or false answers. And it also should give the confidence of the own answer, which could have been a number between 0 and 1. So that's how one of those answers could look like. I mean, this is a real example, but I chose one with very short articles. Many of the articles were several pages long. But yeah, this basically would be an answer. There's article, then a short article, then the second article, both pretty much in the XML text. So you can really compare like both of them separately. Then we have the verification. yeah, in the middle. Oh, and I pushed. Sorry. Yeah, the verification here in the middle, where we basically ask, is this unit current? The model answers yes. Is the subject present? The model answers yes. Is the article complete? And the model answers yes. And have you all articles found? And the model again answers yes. This is, of course, also for us to check, but it's mainly for us. It was so the model extracted the articles, and the model in that moment had to go back and check again what it did and verify what it did, which slightly improved our results. And then the model had to decide, does it need our help? It decided no, my work was good enough with the confidence of 0.9. And then it explains why it thinks that the confidence is high enough. Yeah, so far I will explain a little bit further what we did with this information later. But now I'm going on with, yeah, we were doing the benchmarking. Benchmarking means then showing or trying to find out how well the models worked. We were distinguishing between the task of correctly marking irrelevant text, meaning if the models were able to see, or there's no article on the Messina earthquake, and if they found an article, how good they extracted this article. So here you can already see that some models were better in actually deciding that there were no relevant articles in it. It's also called precision. So they made in 95%, or even 99%, some models made the right decision. There's nothing wrong in it. At the same time, when they made those decisions, they also often missed relevant articles because they marked articles that would have been actually relevant as non-relevant. But then we had other models, and there we can already see the differences. For example, the DeepSeek model here, which was pretty good in actually finding articles, but not so good than other models in deciding that it's not relevant. And then the Llama models, who were somewhere in the middle, and the Quant model. So yeah, you can already see that the models have differences, and it's not just about the size of the models, but I also will go into more detail when we talk about bias evaluation, why those things happen and where are the differences and where do we need to look for. Very interesting was also for us to see how impact can it have when we have no OCR errors in our corpus. So we had the first ones are with OCR errors. It's a smaller sample that we made from the big ones. Also, some students I worked with, they made the corrections manually. And so this would look like how it is with the errors, and the second one would be with the with the no errors text at all. And you can see, especially like the smaller models or the mid-sized models, the Llama models had huge improvements when the OCR was basically perfect. So that's also something that we need to keep in mind. The better the sources are prepared before using the large language models, the better results we get, and we might even be able to use smaller models with the same quality or the same good output by just having a better base. Now I'm going to the second task of the analysis, making qualitative discourse or content analysis computable. Again, just making sure we are with the Messina earthquake case. So just very shortly, what do I even mean with discourse? I mean, I mainly talk about arguments. And there is something in the DH, or not just in the DH, but also in the computational linguistic, that's called argument mining. And argument mining means actually that we try to extract argumentative units from text. It's a task of natural language processing. And I'm showing you here like just a little example of what a typical argument is. I mean, an argument has a premise. The premise would be the first one, EU expansion costs too much money. Then we have a conclusion that it would be EU expansion should be stopped, delayed. And then we have something that is never explicit. It is just something that you understand out of this argument. So when a certain action costs too much money, actions should be undertaken to reduce the costs. So this is the overall conclusion. It's also called the warrant. The first two parts can be explicit, so the premise and the conclusion, but especially for historical newspapers, most of the time you only have the premise. So the newspaper would say, oh, EU expansion costs too much money, dot. They wouldn't follow the explicit conclusion what this means. So that also makes it so hard for traditional methods to depict arguments, because, I mean, it actually sounds quite factual. There is nothing that where you could think, oh, this is an argument. But it is an argument. It's called implicit arguments, because the conclusion comes implicitly with those one statement. And that's very much what media discourse is about. You have a lot of statements, but they implicitly give conclusions. Trying to automate this process, as you can imagine, has not been possible for a very long time, even though there have been attempts to try it. But especially for the newspapers, there was never something that could have been even close to working. And I was wondering, okay, this is maybe something where also the context understanding and semantic understanding of large language models can actually make a difference. So I did, for example, my task was the argumentative discourse unit extraction, meaning within the articles that I already extracted, I wanted to basically see where are argumentative units. Meaning like, yeah, I'm not going to read the whole text here now, but maybe a little bit shorter one would be an argument. So what consequences will it have when thousands suddenly pour over the ruins and find neither shelter nor work and food? Hard criticism is being voiced at the money collected from around the world is not being used better and systematically and is instead being squandered, and so on. So we would have a warrant here, and I just noticed I forgot a B in the warrant. It would be because too few measures for the reconstructions are being taken, there will be negative consequences. So basically this would be the warrant or the overall conclusion you would get out of those parts. The large language models would need to be able to find those parts and to actually also give them an XML structure, like showing, okay, this is an argument, this is the ending of the argument. Again, here we had experiments, and we wanted to know for the model mainly like what are the passages or the units where the arguments are in. We wanted to know how the models deal with ambiguity. So you can imagine, even for us as humans, this task is very much, you can have different opinions of what is an argument or what is not. So there's a lot of ambiguity and also uncertainty, especially sometimes when arguments are very implicit and need a lot of context understanding to actually know, oh, this is an argument. So how were the models dealing with this kind of ambiguity? And how were they also able to add a main conclusion to the units that they found? So again, we used models to compare, this time only 3 models. The very big models, the DeepSeek and the Cloud model, both very strong models, and then the Llama 3.3 model, mid-size model, to compare of how well it works. And also here we had to find prompts, and also here with the prompts we were basically going like, if I had a student to explain what they have to do, I would need to create guidelines. So I create guidelines for the large language models. So I explain the model. You are an expert in qualitative research and augmentation analysis, and you need to find explicit and also implicit or embedded arguments. And then defining what is an explicit argument, what is an implicit or embedded arguments. Then I give a lot of instructions. I can't show it here because it would be also too long. I give instructions what is specific for media arguments. And then I also give instruction of how to extract. So extract it in the text, specify if it's implicit or explicit, then also explain what you did. some explainability. And what is also very important, and I think I forgot to mention this for the other prompt, one very important prompting line is always, if you don't find an article or if you don't find an argument, just write, I didn't find one, there is none. Because if you don't do this, it might just give you something because the task is to find something. So it really, you need to tell, don't do this, or don't say there is nothing, to avoid hallucination. And I also asked the model if you are certain, or if there is a certain amount of ambiguity, ask a human verification, again with true or not or false. Answer could look then like this. It has an argument. Found, it says this is an implicit argument. It explains why this argument is implicit and what would be the main claim of this argument. And in the end, again, does it need human oversight? And here the model decided no. So basically also the answer and then some explainability things. We also created benchmarks here. I showed you one prompt. Actually, the very last prompt was the one that I showed to you, the purple one. But we used 4 prompts, simple prompts that were more open, where we did not define actually what is an argument and what makes an argument. Just leave it more open, saying, okay, parts where there is arguments and where there is discourse and opinion in it. So, and also we always compare simple prompts with more complex prompts. Also here we had interesting results. For example, the very big models would work a lot better if you are more explicit, while the Llama model actually worked better with being more like with less explanations on what is an argument and what makes an argument. So also we already see differences, and I also will in the next step explain why we have these differences. But yeah, accessing the large language models, I mainly used computing environments, either with API or connected with computing power with servers of the university. I'm showing this because I basically just also want to show you that the whole code that I used for extracting the articles or extracting the argumentative units is this here. It's only these lines that were needed to do those tasks. So actually the code that you need to use is very little compared about all the other competences that you need when using large language models. So I think for the availability, large language models, of course, are great, and also the accessibility, because the requirement or the technical requirement is quite low. And even like with the Python input that you got in the last days, you would be probably be able to import your text and to make this code somehow work, to use your prompt and to get your results. So it's not so much the technical challenge. Of course, there is a challenge the moment when you want to use bigger local models. You need computing power, you need to know whom to contact from your university or from HPC centers to get some computing power. This is another point that might hinder accessibility. But for the technical part, it has become a lot easier than other things that we did before. But as I already mentioned, better accessibility does not mean it's less complex. Not at all. It's very, very complex. Just we need different skills, and here we talk about literacy. It's about AI literacy and AI competence. With a colleague of mine together, we wrote a working paper on the implementing generative AI in the historical studies, and here we distinguish between using the tools as using generative AI as a tool or using generative AI as a method. And one needs AI literacy, basically understanding what the models are and what we can do and what they are capable for. But using them as a method also means being competent, meaning technically knowing how to use them, how to evaluate them, and so on. So there are those both things where if using large language models, for example, if you use it just to translate some of your sources, it might be enough to have some AI literacy to actually just maybe know what the models are and where the limitations are. But if you really implement it as a method, then it's really important also to have competence. But I'm also going deeper into this. So AI literacy, the first point important when using generative AI is, of course, understanding what AI is capable of. And to understand what AI is capable of, or generative AI is capable of, starts with basic understanding what large language models are. I'm being quite short here, but I'm just trying to outline some of the most important things that you might need to know before starting even using large language models. In general, large language models you could call them even like having a zip file of the internet. Large language models have been trained with huge amounts of data of the internet. All kind of sources that companies were able to scrape from the internet, less quality or more quality sources. And they they train those models basically by important steps that would be taken here is first to create tokens, which means that the models, they don't get the text that this is, they get tokens. It's called the process of tokenization. It's also a little bit what you did, in the course when you were splitting words, but creating token is not just splitting words, because a token can actually be less than a word. It can be just like the main part of a word. So in general, one token corresponds to 4 characters of a standard English text. And 100 tokens are around 75 words. And with this, then you have the tokens. But the tokens are also not the one the model basically is based on. It's embeddings. And embeddings are numbers. It's basically a representation of the text in numbers in a multidimensional vector space. So the dog would be represented slightly different than the cat, but also they have overlappings in their representation. Let's look at the one sentence here. The sentence would be down by the river bank, ... until they jumped into and the model would have to decide here what is the last word. So on the decision making of what would be the last word here, the model has to consider, of course, what are the words before. And if we look, for example, at the bank, the representation, the numerical representation of the bank here is really different if we wouldn't have here the river. So because it could be the bank with the money, it could be the bank where we sit on, but just the word river in front of it, and that's what large language models are about. They look at the words before, they look at the words after, and within this context, they adjust the numbers, the representation of the word bank. And if the model then understands, okay, it's a representation of the river bank, and river bank is connected to the water, the last word would be water. But of course, this is what foundation models would do. You have you find the biggest probability what might be the last word by taking into account all the words of the sentence, for example. And then you have foundations models who are capable to do this. But the models that we are working with, they are not foundational models. Those models are fine-tuned. They are fine-tuned with a lot of examples that are given. For example, with answer and question-answer examples. So the model basically here learns how to communicate to the users, how to use language to answer a question of the user by a lot of examples where the model is learning on. And then we have fine-tuned model, but that is still not the model that we are working on. For example, if you're using ChatGPT, you have not a fine-tuned model. What you have is an aligned model. The next process is alignment. This is basically also called human feedback. And here you have a lot of people who judge the answers of a large language models. So they would say, this answer is better, this answer is worse. And by doing that, like in a very big amount, the model learns what humans prefer. So then models are aligned. So the aligned model in the end is a lot more than just predicting the most probable word. It's also making sure that it aligns with what you would expect from the model. Oh, I forgot to change something from German into English. Sorry, but this should know what can large language models do. There is some benchmarks to test what large language models are capable of and what they are not capable of. And there's one of those benchmarks, it's called the AGI benchmark. It's called also Easy for Humans, Hard for AI. And it tests how good large language models can do tasks that are not represented in the corpus, in the training corpus. One of those tasks could just look like this. It would need to find like patterns. So the yellow things here, so one with no hole would be yellow, with one hole would be green, with two holes would be blue, and so on. Very easy for humans. You could easily do this task, and the models really have problems with those tasks because they are new. But also the models are becoming more and more better in those, especially also in generating things that are not presented in the data. And one example of this is an example that a researcher did for several years, asking models the question to create an image and other on a plane using Wi-Fi. So this is something you won't find in the data. So you won't find the otter in combination with plane and in combination with Wi-Fi. So of course the models had big problems to actually create those images. But also very big changes in 2025 where actually models were capable of creating a video with an otter on a plane that is also using Wi-Fi. So you see, models are actually getting closer in being able to some extent, very far still from what we would hope for, but in some extent getting closer to creating new context and new create something that is not there in the trained data. And I think also for us in the humanities, what is important to know is ambiguity for the models, or ambiguity for the humans also means ambiguity for the large language models. So we expect sometimes a lot from the large language models, but there are tasks that also humans cannot agree on. And one of those tasks is, for example, also sentiment analysis. Sentiment analysis does, for example, decide if some part of text is positive, negative, or neutral, or maybe both. And I found from a colleague a very nice experiment where she had researchers, 3 annotators. She had them annotating texts and compare how often they agree. And she found out if you have 3 annotators, they agree in less than 50% of the time. So the human annotators could not really agree on what sentiment the text is in. If you only want 2 of them to agree, it was a lot higher than it was already close to 80% of agreement. But here we need also to understand, so when humans have problems in the same way to actually judge on what is positive, negative, or neutral, large language models will have the same problem. So if the large language models are not working exactly the way as you would do it, it's not the problem of the large language model, it's the ambiguity of the language as it is. Going over to AI literacy and competence, being responsible with the usage of large language model. I just want to check the time so that I'm not like completely getting over. Yeah, I'm doing this a little bit fast. So of course, what is also very important is that we use large language models in a responsible way as researchers. We have different kind of large language models. There is really open source, open weight, and then there's closed source. And ideally, as researchers, we could use open source. Open source means that also the data is open, and we could actually judge on what data the model is trained on. The only problem is, especially for researchers working with not so representative languages or with multilingual corpora, there's just no selections that we can make for open source models that would work well now. And I think it's a really important future step. So there's the open weight, where you at least can see how the models were trained, and the closed source, for example, ChatGPT or Claude would be closed source. You don't have any insight. It's a complete black box. And so if you use large language models, it's also important to know, okay, there are different types. And for different types of sources, you might consider different types of models, because we have sources that have copyright. You cannot just give them to ChatGPT. They have personal, sensitive information or licenses. So I think for researchers, it's always important, especially when they use material in collaboration with national libraries, that they try to handle this material as ethical as possible and not just give everything to the big companies. And of course, we also need to decide, when we have different sources, what models work for historical languages, handwritings, low-resource languages or images, audios, and films. Minimal computing is also an aspect that we might consider, that we always try to use models that are as small as possible, but also in combination with the quality that we need. And accessing the large language models also beyond the commercial tools, there are possibilities interestingly, I also found only recently in Switzerland they created a chat. It's called Luma, which is completely open and secure. They only use local models, and it's open for everyone without login or registration. So definitely also an alternative to the big models or the companies. Then, of course, installation on your computer and through HPC clusters. And later in the workshops, you will also learn more how you can use APIs to use the models. And for the pipeline, for the implementation of the large language models, we also created a pipeline. I'm showing this mainly because I think it's really important to actually start, before you use the model, start with creating the data set. I call it the evaluation data set. And I just think it's really important because it just forces you to do the task that you want the model to do first on your own, and to understand, okay, what are your own limitations? What do you expect? How can you do it? And it also makes you then a better evaluator to see what the model is doing when you just started doing it yourself before. That's why you optimally start with creating data set, ground truth, and then creating simple prompts, then do evaluation, bias evaluation, output evaluation. I also think that the bias evaluation is a really important aspect, and that's, I'm going over this now, also, one very important aspect of the AI competence is doing critical bias examination. I mean, everything is biased when we use tools and methods. The sources that we are using are biased. The models that large language models are trained on, or the selection processes are biased, and in the end, the model itself creates bias. And I was mainly interested in understanding mainly like, okay, why do we need evaluation? Of course, to assure quality, to have transparency, but also it should be really an integral part of the historical sources. And we did an experiment or a study where we wanted to learn how the model itself biases. What are the biases with the models? So we are going with the Messina earthquake case study, and we wanted to see, one of the first questions was, how well work the models for non-English data? And actually here we were expecting that the models work better for English than for the German and the French. But here, surprisingly, we found out that there was no bias for those languages, no difference, at least for the models that we used, for the mid-size and also for the large size. There was it seems those languages, the bigger European languages, were represented enough so that there was no biases. And we also tested if different prompts, like if you use the prompt in French instead of in English, or if you use the prompt in German for the German sources, if this has an impact. And here we also found out it has no impact. The next question, we wanted to know how well work the models for domain-specific knowledge. So we wanted to see, when we asked the model to extract newspapers from the Messina earthquake, how well does the model can judge what belongs to this earthquake without giving this information. And here we had good results for the articles that had very clear indicators like Messina in it. But we also found that models failed often to integrate contextual knowledge from various sources, which means they had problems to combine geographical, temporal, contextual knowledge. I'm giving here one example. So I told you that the Messina earthquake took place in Sicily, and mainly Sicily and Calabria. And here we have an article that speaks about the earthquake in Calabria. It says, earthquake in Italy, Monteleone, December 28, extensive damage was done here and at Mileto, Cantazzaro, San Giorgio and the other Calabrian districts by a violent earthquake which occurred at 5:50 o'clock this morning. So it's definitely talking about this earthquake, December 28, but in the Calabrian region. And model 3.5, really a very big model here answered, while this article does discuss an earthquake in Italy in December 1908, it appears to be reporting on different seismic event that occurred in Calabria. But in the next sentence, it would say the Messina earthquake affected Sicily and Calabria and was much more devastating, killing over 80,000 people. So the model knows the earthquake happened also in Calabria, but it was not able to combine this information for one task. And I found this was also very interesting finding that even though the model might have enough sources, it still can fail to combine those sources to answer those questions. Lastly, we also found out that the temperature setting can actually make this worse or better. So the first here shows the analysis with 0.0 temperature, which is very deterministic. That means it forces the model always to use the most probable tokens or to use the most probable sources for the answer. And here we have the temperature 0.1, a very slight difference. But if you look, for example, at the DeepSeek model here, and the DeepSeek model below, just changing from 0.0 to 0.2, changed completely how the model reacted and how it was able to integrate the knowledge. And that was also very interesting for us because just such a little change could have such a big impact on the model output, which we, of course, also consider as a bias because it shouldn't have, like, a model shouldn't completely behave different just by using 0.2 temperature. And what we also found is that especially the proprietary models were very overconfident in their answers. When they had to answer, do we need a human to oversight for this, the proprietary models, the GPT and the Claude, they almost never said yes. They always thought that they are very confident and the answer is correct. And this is alignment. This is what alignment does to model. So definitely those big models are trained to align in a way that makes sure that it actually is confidence in their answer and gives also the most confidence answer. And then the other models like DeepSeek or the Llama models actually were better in communicating when they have uncertainty. For both also the article extraction and the argumentative unique extraction, we ask the question how they deal with uncertainty and ambiguity. And I already showed you this graph here, and what I also found here very interesting. I already showed you that the big models, Claude and DeepSeek, both worked not very well when they had quite not a very clear definition what an argument is. You can see this in the first one here, in the yellow one, that they didn't work well, and also with the blue one here. These were the prompts where I left the definition quite open. What it was very interesting here as well is, however, the Claude model did not perform very well because it actually had a very high precision. That means most of the time it said there is no argument, and it was almost always correct also when there was really no argument, but in 50% of the times it did not find the arguments. That means that Claude was only going with the very explicit arguments. But the DeepSeek model completely behaved differently. It had a precision of 0.5. That means that in 50% of the times it actually said there was an argument when there wasn't, but actually was really good in finding all the implicit arguments. So even those two models, big size models with the same conditions, have completely different outcomes and completely different behavior towards ambiguity. And I think that's very important to consider as well, like especially like with models that are made for the general public, they should are trained to avoid ambiguity, just like Claude. Claude is very much trained to avoid ambiguity, to give people answers that are not saying this is possible or this might not be possible, not giving you an answer that says like, oh, the capital city of France is Paris, but also Rome might be slightly likely. It shouldn't give this answer. It's highly trained to say, no, it's Paris, I'm sure. But the model itself always have like probabilities. So the most likely will be Paris, the second most likely will be other cities. So it's all the alignment. But for using it in the humanities, we need to deal with alignments, and that's why sometimes those models don't work well. The same button also for the article extraction. I already also showed you here the big models that were much better in the precision, like finding the irrelevant articles, which means that when there was uncertainty, they rather went with the option it's not an article than actually giving you the answer this is an article. So they decided to be safe and only go with the articles that they were really sure that they are correct. Not giving the one that they are uncertain. But also, unlike other models, they did not say, okay, this might be possible, please have a look at it. They just didn't give you the answer and already decided it's not relevant. So in the end, and then that's also how I end this talk, is the decision what model worked the best for the both tasks. So in overall scene, of course, the large size models had overall better results. But also we had to see what were the best models in the best balance between precision and recall. It were the llama models, what models that had the least were least affected by parameter change. It was also the llama models. Models with the best confidence levels, it was also the llama models. Confidence levels like in deciding if they're uncertain, how good can they communicate it. And also models with the best ratio between size and quality were also the llama models. So here the researchers also have decided between, of course, overall best quality of the outcome, but how good can actually a model involve me as a researcher. And I think it's really important how good actually you can intervene when the model is uncertain. Very, very last slides, becoming part of AI development. I think knowing all of this, I was more and more convinced that the models that we have might not be the best models for the research in the end, or at least we need to think further of how to create maybe also models that are really better suitable for the research that we are doing. And I feel like especially humanities researchers are a very important part in actually making this possible, making this development possible, just for example by creating knowledge graphs, ontologies, which would make models a lot better, or also by helping in developing models that actually have an understanding of heterogeneity or contextual understanding, talking about different epochs or cultural differences, ethical differences, because the models that we have so far, it's just like a huge pot. It has everything in the same pot. Is it the Middle Age or is it yesterday? It's in the same pot. So the models are not really aware, okay, this is actually from very long time ago and this is from now. So it would be really helpful also to have models that are aware of different historical epochs and different language changes and cultural changes. And that's how I also end this presentation. Thank you very much.
So now to the questions. Do you have questions?
Yeah, thank you very much for this fantastic presentation. I had so many questions, but you had answered almost all of them except one. I would like to return to the first part of your presentation. Could you please tell us more about how do you usually refine your data set? How do you remove garbage from your data? Yeah, thank you.
So it was basically the part in creating the evaluation data set, right? Or basically creating my data set. Yeah, that is really a very good question, because as I have been also showing, the worse the data it is that you start with, the worse the results are in the end. So how, as a researcher, you define what is still good enough? For me, it is very important also to have some kind of comparability between the sources that I use. Let's say if I have around 80% errors in the sources in general, I would consider it still well enough. If we go like to 70% correct and 30% errors, that would be really more critical and more critical. And also, so the decision is, in the end, if you use like newspapers from different archives, to kind of decide on newspapers. Of course, first, for me as historians, I want to decide on the variety of the newspapers to show different perspectives, of course. But then when it comes to the quality, to see, let's make sure that all of them have at least 80% correct OCR. And that's also how we try to kick out like newspapers that are not good enough. If we really want to consider a newspaper that is not good enough, we might consider even doing re-OCR them, like doing the whole process from new. For very large projects, sometimes this is just not possible. So I did it for smaller projects where I said like, oh, I really want to have these newspapers included, but it cannot be included like this, because every result I would get would be biased, because I cannot find the words, because there's so much wrong. And we had so many of those examples. So I was working so much with the data. And for example, with the Austrian National Library, we also figured out that for a few newspapers, they used a wrong model to transcribe, which means those newspapers, and that happened not for the whole period, it mainly happened for a period like during the Second World War. For some reason, I don't know. A wrong model was used, and you couldn't even know as a researcher. And we've only found this out because we were doing some research and we were looking at it, and we felt like, this is very interesting. The Second World War is missing, and it cannot be true. So we were digging deeper and finding out, okay, there have been real problems. And if you cannot find those mistakes, actually, your whole outcome is wrong. And that's also why I think, as a researchers, we really need to have also high competence to judge on how good the sources are. There are also methods where we can actually judge on how good the transcription, or the transcription is, to make sure that the process is really good. And if we have, for example, 80% correct OCR, we can also then start with the post-OCR correction and make it even better. And that's at least how we decide how we create the corpus. But in the end, it needs to be comparable, the sources, and that's important for the decision. I hope this answers the question. Yeah.
Thank you very much. It was fantastic, and it was excellent presentation. I think you already present what you did last year or what you will do next year. It was very nice. My name is Aitaj from the University of Eastern Finland. First, I saw your name 5 years ago that you published one paper with Jani Marjanen and Eva Petzer and Pierre Carr, Stefan Erch. That you are discussing the historical newspapers and recommendations and discussions. And regarding your presentation today, that you take the example of the earthquake. From my case, I take one of the war for Russian-Ottoman relations end of the 19th century, and I discussed Finnish and Bulgarian newspapers, but I haven't used this LLM methods. But I am familiar with the ChatGPT, what not with others. For this article or project that you are working on, are you really testing the models, or are you really want to see the experiences of the earthquake? At the beginning, I was sure that you were trying to see the experience of the earthquake, but in the middle, after the middle of your presentation, I see that you are discussing all the models. I am not familiar with other DeepSeek and others, but what kinds of methods do you use for topic modeling or coding your findings? Are you using NVivo and others to coding or categorizing your data or extracting your data? This is my first start. I have a few more.
Yeah,
if we have time, sorry.
It's a very good question. So I started doing this work 1.5 years ago, and the first part, of course, was making the methods work in order to get to the sources to go to my findings. So my findings of the work that I'm doing are not yet there, in findings in the sense of I still haven't learned how different countries talked about the Messina earthquakes. So I'm still in the process of making methodologically work this whole process. I must also say that for the first time in the 10 years where I work with newspapers, I'm happy with the corpus that I'm creating, because it actually it satisfies me in the way that the quality is good, and I'm confident it's representative for me as a historian to work with further it. Maybe I can find the slide. I jumped over this. Sorry, I have to click a lot. This here. So what I try with the automation is to make the corpus, the huge millions of newspaper pages that I have for the comparison, to make them manageable. The first would be the relevant articles, to find them. That already makes the whole corpus a lot smaller. Then finding the articles with the argument units, where there are argumentative units in it, makes it smaller again. Having in the end, basically, to manage a corpus that I can proceed manually afterwards. So in the end, I would have articles with argumentative units in it, also showing me what are the claims in it, and I will work as a researcher and make sense of this in the end. So I'm not applying any other methods at this step anymore. I'm not doing topic modeling or any further thing. So I'm using then those parts that have become manageable. So for millions, I would probably, I'm not talking about millions if I think, when we start with millions, but I would say for the Messina earthquake, we have about 30,000 articles maybe from the areas that I work with, and minimizing them to several thousands of them that become kind of manageable for me manually in the end. So that's the goal of the whole thing, and qualitative analysis to get to the manageable parts that where I, as an interpreter in the end, do the final work, the contextualization and the interpretation. So the final interpretation is not technical or digital anymore. I hope this kind of answers the question. Or maybe you...
Thank you. I was thinking, how do you use different AIs, such as... Yeah, how do you upload your data there, or do you use them as like hunters for your articles? How do you combine with these different AI models to your research? And for Messina earthquake, you don't use Italian newspapers.
I do, though.
Yes. I haven't seen. Okay.
No, not in the evaluation, because the Italian newspapers are a special case. They are very bad in OCR, unfortunately, so we need to do some further steps to make them comparable good than the other ones. So that's why we didn't include them to this experiment, because the OCR is really bad, unfortunately. That's with the Italian newspaper problem. So you want to understand how exactly we use the large language models. Basically, what I am doing, I mean, and you will learn a lot more in the workshops done, though. That's why I didn't go so deep in this, because this is what you will learn now. So maybe I don't even explain more, right, Anna, because this will be part of the workshops, basically. Yeah. I just want to mention it when I decided to use also local models, what you need to consider if you want to use them. I'm not talking about now the technical part, because you will learn this. Just when you use local models, you might get in contact with your university or contact computing centers that have computing powers to actually, that they give you GPU to process large models. And that's a little bit more complicated, but this is always collaboration then, where you actually get access to big servers that host those models locally. This is for big projects, at least in many countries, you can apply for those things, and you get then GPU. But this is a process that every country is different. That's why I didn't want to go too deep in it, because the experience that I make in Germany might not be your experience here at all. So it wouldn't help you to show what I can do in Germany for what you can do here. But the best is, of course, contact the university and ask what are the possibilities for using models that the university might host locally. And the rest, yeah, you will learn in the all-day workshops that you have now.
Yes, thank you. And just another two questions. How do you avoid the very widespread and typical problems when using OCR tools? Very often they, be it scriptorium transcribers or other OCRs, especially in case of newspapers, very often they merge two lines from different columns into the one line. How do you avoid this problem? And my second question will be, you mentioned about the evaluation of OCR results, and am I correct in assuming that you use Levenstein Python library in order to evaluate OCR results?
Okay, yeah, it's also a good question. So for the first question, the process of transcribing, for my research project, I decided to not do the process, but take what they have in the libraries, because in the libraries, they have done this process already. They use transcribers, they used scriptorium or whatever to transcribe them. Transcribus, for example, has trained an excellent model to do the layout very well for the newspapers. But you're right, there are sometimes mistakes in the layout. And the question for me is, I cannot, for the really million of pages that I proceed, I cannot do this, because that's the task of the national libraries. But also the national libraries, they have the problem that they might have done some OCR 20 years ago or 10 years ago, and now it's not meeting our standards. And that's a big problem, because then also the library needs to decide of, do we redo the whole process, or how are we proceeding? Of course, we as researchers, we will always go to the library and say, like, give us the best. But it's really, but if you as a researcher start even with this process, you will never get to an end. And that's why I decided to actually start with the transcripts as there are in the archive, and make sure that the newspapers that I make meet the standards that are necessary. This is the least that I can do. Everything else would be completely unfeasible for me to redo the whole process. But there exists, you had the Transcribus workshop, I wasn't here, but they have specially trained models for historical newspapers that are very well aligned for the layout, and they work really well. So there are methods that work well. The second question was, sorry. Yeah. So that's also a very, very good question, and I couldn't talk more about it. We don't have ready-made evaluation methods for large language models yet, at least not for the specific task that I had here, because the tasks weren't done before. So with this article extraction, I was the first researcher doing this task. And so Johanna Mauermann, who worked with me, she created this whole evaluation process. It was 2 months' work. She really put a lot of work in, but it has become a notebook of 15 pages of code in the end. So you can imagine it. It's actually, and that's also what I mean with just accessing a large language model is maybe not the most difficult thing or complicated thing, but it really gets complicated if you start evaluating, trying to figure out the quality, bias evaluation, and so on. So everything of this is actually open access. So if you try to find it, you will find it in the internet. So we published everything open access, also the notebook, how we evaluate it. But it's a complex process of comparing model output with ground truth, with specific models. What we used, one of the Python packages we used was the Levenstein similarity, for example, to see if the OCR didn't, if the model didn't correct the OCR or didn't change anything in the article to make sure that there was no hallucination, for example. So the Levenstein was one of them. Yeah. I did not hear, sorry. Okay, maybe you take the microphone.
Sorry,
maybe we continue the conversation.
We can continue later on, but also maybe other people want to add something, and I just quickly, if I may, also add. So this is true that OCR done at the national libraries is old for almost everyone, and it's sometimes difficult to redo it for the whole collection because it's very expensive. Yeah. But in many libraries, including here in Latvia, we do corporate our data sets on demand, and for these data sets we redo the OCR to make the quality better for this particular data set. So if you see something that is not good in the archive, then we redo it for you. If it's extremely large, then it will take more time. Just take this into account. And for example, these problems such as like merge lines, and there might be other problems. Sometimes you just have to look at the pre-processing steps and go one step back and do it correctly. And this is also how these materials are displayed in different programs. And sometimes it's not the problem you think. But if you really cannot go a step back and reclaim your correct data, also language models can split your words. Yes, then this is all possible. Do you, audience, please, do you have a question? I have my own question as well, but if you have one, then.
I have a small terminological question, but I thought it's worth asking you because you also perhaps get in the situation. So when I talk about computationally or automatically working on something, I'm fine with it, but then I have to compare it with manually. And actually, I'm not doing any manual work, I'm doing digital. Are there some better words? Do you understand my question? So it's more like qualitative reading with eyes and comparing with your expert knowledge. It's not really so much manual work, but we still are using this automated and manual, right?
Yes.
Computational and manual.
Yes.
Are there some better words or expressions how you can contrast those two different methods?
Well, there are many words actually. There is this close reading and distant reading words, which I never really liked so much. And then there is also something like scalable reading, blended reading, when you combine those, basically. Then there is also something like deep reading and reading from far. So there is many words, and well, I changed the wording over time. I used close and distant reading for some time, but then I changed to more like also deep reading or just or close examination. So there's many words, but I don't know if I can give you like a really good word or a better word than we use so far for this process of. I also sometimes really distinguish between quantitative and qualitative. Qualitative can be a lot, but qualitative also always means like examining closely, and that's the and really going deep into the texts could be also one wording that we could use. I don't know if maybe you have a suggestion what you
No,
would.
no, I don't have. But just when I'm comparing and saying I'm doing something computationally,
Yeah.
and then as to put the quality sign of a human, I said I also did some manual work. But
Yeah.
actually, I was not doing any manual work. I was
That's
just staring
true.
at my computer and scrolling. So
Yeah, it's
I
not
feel sometimes
yeah.
lying that I'm saying I
Yeah.
did some manual work, but
Yeah.
there is no better term. So I just asked, maybe
Yeah.
you know.
I think in the keynote lecture yesterday, she used the word deep reading. Yeah, also one
Yeah.
possible.
I sometimes say subjective versus like automated. Yeah. But may I ask my last question, because it's very current for me and my team. So we use a lot of API access and oftentimes commercial models for several reasons, and depending on how large is your output, the cost goes up or down. So sometimes we concatenate, like aggregate several tasks in one prompt, and sometimes it seems benign enough, like extract articles on particular topic and then also categorize them. But sometimes it's more sinister, like maybe you would say like normalize or correct the OCR in a text and then do the extraction of articles. And we want to do this because it's cheaper, it gives back the like less tokens.
Yeah.
But is it, in your opinion, is it acceptable at all, or you would suggest do it separately at all times?
No, it's totally acceptable for many reasons, actually. Cost is one thing, but also I don't pay, for example, for the local models that I use over the university, over the servers, but it's also time. A lot of time if you do step by step. And then there is also something like using more resources than you might have, which means like also thinking about sustainability. And I would always say if you evaluate your results and they are good enough for you as your judge, with the combined tasks, it's definitely the better way to go than maybe have 2 or 3% better results with the separate steps. And that's also in this paper that I wrote with my colleague Cinderella, that I showed in the presentation. We also outlined this here. It also falls on the minimal computing aspect. So if you get good results by combining the task, being more minimal, it's definitely the way to go and the better way. But that's also my ethical researcher judgment. And I would always say that maybe 2 or 3% better results are not worth it to use double as much energy, because we already use so much energy by using those large models. So,
thanks. Last question.
Do you use any tools after extracting your data to code them, to categorize them? Which tools do you advise to historians who are working with historical newspapers after the extraction of the data from the newspapers? Because categorizing and coding and discussing the arguments is also important. Thank you.
Yeah, it's a good question. I use Excel, very easy, because I really just like to have everything in one place, like the whole metadata together. But I also, when I was doing qualitative analysis manually, I'm talking now again manually, but when I was doing it by close reading, I used tools like Atlas TI, for example, for the coding, and also to say more and more of these tools like Atlas or NVIDIA, they have also large language models included nowadays, so giving you the possibility to combine your research in those platforms with large language models. So this is also more and more becoming a thing for the qualitative research. So,
Okay,
thank you.
So now we go to the coffee break. In approximately half an hour, we meet for the practical workshop. I'm working with large language models and APIs. So.
I'm staying